If you're a producer of plastic parts, then you're well aware of injection molding machines and the molds associated with those machines. We've developed an injection molding database that allows you to quickly match molds with the injection molding presses that you have available to you. This database is made up of 2 Excel workbook worksheets. One is called Injection Press, where you would enter each of the rows represents about 45 pieces of information about each press. And the second worksheet is called Mold Database, and it's where you enter about 35 pieces of information about each of the molds you have. You can have up to 9,999 molds and 250 presses associated with this particular version of the database. After, if you've worked with presses before, you realize that you have to ask a series of questions to match a mold with the presses that you have available. One is, does the mold fit within the press confines? Is the clamping force appropriate to keep the mold in place? Is the screw type appropriate for the mold to for you to inject enough plastic into the molds so that you don't have any voids? Is the mold opening large enough? Is the injection molding machine large enough to basically handle the mold that you're trying to match with a press? I'm going to reduce the size of this a little bit so that you can see more of this particular database. It runs on both the Macintosh and a Windows 7 or Windows 8 based computer, and it can basically find the matches, the press mold matches within a few seconds. Basically, some of the other sections of this database include the screw L/D ratios. Is the press capable of injecting enough plastic to completely fill the mold? So that's max shot size. If you have a number of parts, then there is an automation test that tests to see if the automation necessary for you to create enough parts for the customer is appropriate. Either is it a spruce picker type automation technique, or is it a robot controlled press? There's also a section here for, does the hoppers that you have available have the appropriate capacity to handle the amount of plastic needed to continually feed the mold, as well as is the dryer throughput capacity capable of keeping up with the number of parts that you need to produce. In the mold database, there's various sections for how much clamping force the mold can handle, what the grams of shot size are, and various other parameters such as the annual press usage. Do you have to have several of the same type of mold available because of the annual units that you need to produce? So that gives you a little bit of an idea of how this database works. You can use the buttons associated with it to jump between the two databases. You can look at a normal view which we're looking at now, are a full screen view, which allows you to see more of the rows of information. You can hide some columns so that you can see the maintenance and operating parameters. For example, if your maintenance organization keeps a tally on which presses are available, which are in use, IU, or which are unavailable because they're being maintained, either greased or hoses replaced and so forth, or is the press available? So how would we use this particular database to our advantage? Well, what we would do first of all is go to, I'm going to go back to a normal view so you can see the row column headers. You'd click on column A3, you pop down the list, and you choose a particular injection mold. I'm also going to make this a little bit larger in size so you can see what I'm doing. So you click on A3, you choose a particular mold. I'm going to choose an automobile left rear bumper. The data for that particular mold is then locked in, and you run all of the filters. The filters are, is the mold dimensions appropriate for the press mold match? Is the screw type okay? Is the maximum mold opening capable of handling the mold? Is the shot, the max shot okay? And if automation is needed, then is there an automation match? You can run each of these filters separately, or you can choose to filter even further if you need to do that. But all 5 of these filters can be run by just clicking the Run All Filters button. As you can see, the little filter icon shows up on each of the cells, on each of the columns where the data is being filtered. And when we're completed, you can also see in cell B2 how many filter, or how many molds and presses, how many presses are left to handle the molds. So after we're completed, we can get a little overview of what's happened. There are 31 molds in this particular database. They were reduced to 10 when we did the screw type OK test. They were still reduced to 10 when we did the maximum mold opening test, as well as 10 left when we did the maximum shot size. But we reduced to, when the maximum shot size was tested, the count was reduced to 4. And when the automation match was tested, the count was reduced to 3. If we maintain the maintenance part of the database, we can also click the available presses, and we see that we're reduced to 1 press because all the other ones are either in use or unavailable at this point in time. I'm going to now decrease the size of this just a little bit so you can see what's going on here. So the maintenance part of the database was shown here. We're hiding columns 21 to 44 because that allows us on smaller computer screens to not have to scroll left and right as much. If we want to view all of the presses again, we would click the database toggle and we'd see all of the presses. If we want to show the parameters, which basically these are the system parameters and the maintenance parameters, those are explained. Instructions for using the database are shown, or we can hide those parameters to see more of the database. And finally, we can lock the database so that it cannot be modified, or we can unlock it so that the databases can be modified. that's all, and